I'm Tim Spann. I'm located here in Princeton, New Jersey, United States. I'm a principal data flow field engineer at Cloudera. I cover things like Kafka, Flink, NiFi, different streaming technologies that you could use for various real-time and event-based applications, things like IoT, real-time data ingest. And that brings us to what I'm going to be talking to you about. My talk is about how to use things like NiFi, Kafka, and Flink to solve complex applications that span from the edge to on-premise devices, distributed in nature among different clouds, and do this using open source tools and technologies in a very simple, low to no code manner. You could just take SQL and drag and drop and build real applications. Join me. Thank you. Hi, and welcome to an introduction to the Flink stack. I'm Timothy Spann. I'm a principal data flow field engineer here at Cloudera. And today we're going to cover different things about streaming using the open source technology that's out there. The main ones being Apache NiFi, Apache Kafka, and Apache Flink. I run a number of events, and I do a lot of blogging, and I put a lot of open source code out there. So please feel free to join me, and I'll send out more information in the Ask Me Anything and in the Slack channels. So please feel free to interact that way. We also have a Slido. If you have any questions, put them out there early, so when we get towards the end of the session, we'll have them ready and I can quickly go through them. And if things can't be completed in time, we could go to one of the other rooms, or I'll give you that information in another way. So hopefully we'll get through that. I do a meetup. It is local to the East Coast of the United States, but now that everything's virtual, everyone can join. We record everything to YouTube, so if the timing isn't great for you, you could just come back at a later time. But through the Meetup site, you'll get all the information. It's a great way to learn about different technologies. Also, if you're interested in speaking, we look forward to anyone who's open. Just contact us, and we'll go through a schedule and figure out maybe when you can do a talk. It doesn't have to be long. It could be a 5, 10, 15-minute talk, just to keep it easy. Now, when I talk about my Flink stack, the first thing that comes up and the most common use case for me is I want to be able to run things at the edge. Behind me, I've got a number of devices, and this is a very common use case that's a little difficult. How do I run a machine learning model or a deep learning model, in a device? And then how do I continue that processing, in a cloud environment easy? I'm using Cloudera's data platform to do this. This way I could just press a couple of buttons and have full environment set up with a full set of security and management governance. So I don't have to worry about how do I plug this into this project? How do I make sure I have security on? How do I set up logins? Those things are not fun. I want to write applications. I want to, move data around. I want to run machine learning models and push them to edge devices. I don't want to worry about, how do I start up a cluster? How do I make sure it has permissions to talk to the other services? How do I make sure I have all my data in a data lake? Those things are not things I want to worry about. So it's good to have an environment that lets you easily do that. And it's literally a couple of clicks and you're ready to go. That is a nice experience. So if you haven't heard about it, take a look. It's a real game changer, makes things a lot easier. So I mentioned Edge AI there, and that is really a big use case for us. Now, if you don't want to run or don't have deep learning models yet, it doesn't mean you can't run functionality there, even if it's a simple Python script that just, reads a file or grabs a sensor value or does something a lot simpler, that can be run at the edge too. What's nice here using these open source technologies, we support a lot of different users, a lot of different frameworks, so you don't have to be stuck using one thing or another. We support using multiple development languages. You're not stuck in a box. We support tons of devices, tons of different data sources, tons of different clusters. So I've got my 3 types of users here. Hopefully you fit into one of them. If you're a cat, please contact me. I like cats. Mine wears a tie. You're a cloud data engineer, which sounds like a good title, but someone might call you something else. They might just call you a programmer or a DevOps person or a big data engineer or just an engineer or a software engineer. It seems every company has a different name for what people do, and most people tend to have to do a lot of different tasks. But I'll say this set of skills or things you need to do tends to fall around ETL, ELT, getting data, moving it somewhere, doing some coding, usually in Python or Java. You're going to have to interact with databases. It's usually with SQL. You might have done some streaming, whether that's Kafka or Spark or Storm or NiFi or Flink. Lots of different options there. And in today's world, you probably have to use some cloud. Hard to get around that. If you're a cat, you're probably eating and quite lazy. They like to be in the camera shots. Even they can use some of our tools. It's very straightforward. If you're an artificial intelligence, welcome to the talk. I know you could do a better one. Let's talk. So you can already run, I can already run those AI algorithms in Apache NiFi. I can run them in Kafka streams. I can run them in Apache Flink. I can run them in Minify. I can run them in a cloud environment with Cloudera machine learning. And I could use all those native MLDL tools that I have in those specific devices. If you have a NVIDIA Jetson, they've got a great set of native libraries. No reason not to use them. Same with Intel Movidius or Google Coral. And there's a ton of other TPUs and GPUs and specialized processors like I got one right here. A ton of these have their own little algorithms or libraries. Use them. They're usually the quickest path to getting something done. To switch everything to one framework could be a pain. Most of them will let you translate a model or translate code between them without too much difficulty. Don't get caught up in trying to make the perfect or single library for every use case. You're not going to be happy, and you're going to get stuck on things that don't really give you any value as a data engineer when your job is get things deployed quickly, stably, at scale, knowing that within an hour someone's going to ask you to change the whole thing and scrap that whole cloud and then move to a different one. That happens. The essence of Flink is these 3 tools together. I've been doing Apache NiFi for a long time. It is a great starter tool to get things done, whether that's loading a file, taking an image, connecting to machine learning. It does a lot of the heavy lifting that you used to have to write by hand. So to replace, hundreds of Python scripts and a shell script over here and a cron job over there, and maybe I'm using Puppet, and maybe there's a little Java app, and all these different things spread along entire set of all your servers. NiFi really makes that easy with a graphical environment where you can track everything going on. And we'll dive deep into that. We've got a decent amount of time here. So we've got time to go through the hands-on, and I'll show you what you could do with NiFi. So we get the data, could be from an edge device, could be from different services, REST endpoints, all different things. I get the data, clean it up, find out what it really is. If it's structured data, I want to look up a schema to say, yes, this is what it should look like. These are the fields, these are the types, this is if it's nullable or not, get it cleaned up, validated, push it into Kafka. So now I can distribute it wherever it needs to go. And I'm not just tied to one, user of that data. This comes in importance because this is a nice way to isolate the concerns. This is those classic computer science where I'm separating my different applications. This is also great. It's asynchronous, disconnected, distributed. Now, whatever came out of NiFi, whoever wants to read it, I can have as many consumers as need be. Another line of business comes in, another developer needs that data. I don't have to write a special interface to them. They don't have to know anything other than the data is coming out of this topic and this set of Kafka brokers. Here's a schema that says what the data looks like. That's my contract. Perfect. And I can monitor that from one system to know, oh, this new application hasn't been reading the data or it's slow. Very easy to do that. And one of the best applications to be reading from these Kafka topics is Flink. It's a great framework out there, easy to use. You write a simple Java application, or I'll show you today just a line of SQL, and it can do some powerful processing on that Kafka data as each event comes in. You're not waiting or doing some point at time. I can run Flink as continuous event processing, do some complex work there. In a simple SQL statement, I'll show you how we're doing, take from one topic, do some cleanup, and insert it into another one with a simple SQL statement. That's really my data pipeline for Flink. And if you haven't guessed, I should spell it out why I call it Flink. The FL is for Flink, the A is for Apache, the N is for NiFi, and the K is for Kafka. Sometimes I say the K is also for Apache Kudu, which is a really good store for your data that supports NoSQL and SQL, performs very well, and works really fast and well with these types of data. Like I mentioned before, Edge AI, these things are usually time series where I have a timestamp and I have data and it's always coming. And it could be consistent every second, every minute, or in chunks, but it's coming and there's a new timestamp. That data is great in Kudu. Very easy for me to get it there. Very easy for me to query it, use it in reports, use it in Cloudera visual apps, use it in machine learning models. It's a great option. Could also do Apache HBase. Similar idea there with Phoenix on top of that to do my SQL. You've got options. This is just the happy, easiest path that I've seen. So there's a lot of Apache tools out there that we use to do some of this, and I'll show you a bunch of them. Apache Tika is nice. I have a processor, which is what we call our custom logic in NiFi, that uses Tika to convert between things, because sometimes your data isn't something, very easy and quick to read. It might not be a CSV or JSON file or XML. It could be something like a Word document or Excel. Using Apache Tika and some of the other Apache tools, I can easily process that data, take it out, put it somewhere else. We mentioned HBase for storage, Impala. Apache Hue, I'll show you, is a nice open source tool to do your SQL, see all your tables, regardless of if they're in Apache Hive or Apache Kudu or Impala. Our big three in the middle. OpenNLP from Apache is a nice way to do text processing. It's a nice library if I want to pull out different things like locations or places. It auto identifies those. Again, a nice simple use for machine learning that's been there for a while. Minify, if you can guess, is a small version of NiFi, because sometimes I don't just want to have the edge devices pushed to me directly, which some of them can over TCP/IP or UDP or MQTT. I might need to put an agent there. Sometimes I need to do that with an old SQL server or some old machine you have sitting in a basement somewhere that produces data, but you really can't call into it, or there's no modern interface. I put a minify agent on there, and it could read a local file. It could trigger a command line executable, whether that's Linux or Windows, and could do some secure coding there and transfer that data to a NiFi cluster where I could do more work in a modern distributed environment. We have C++ and Java versions out from Apache. They run very quickly, very easy to code, and I can run my edge machine learning models in there as well as other code. Makes for a good environment. MXNet is a really powerful open source library for deep learning. And because it supports as one of its languages Java, I can plug those components into NiFi directly, or I can run them in one of the other tools, whether that's in Python or another language. Finally, the last one is very simple. The registry is where I put my code. You got to have some place to put your code where you can have versioning. I can run my DevOps tools. You expect to be able to do development processes, so we've got that there. OpenNLP is nice because I've added this processor which you could download from my GitHub, and this lets you do some simple processing. Uh, it could come in really handy when you're analyzing text data. I want to be able to pull out all the names or locations, those sort of things that are normally identifiable. It's helpful. Now, what's nice here is I haven't dived deeply into NiFi yet, so what you're seeing on the side here is not a diagram of the code. That is the actual code. What we're seeing in the middle here with the flow file details and attributes is how I have access to see and change that data at any time. And that includes what we call attributes. This is metadata about your data. So if you don't want your data to change as it comes through the system, I could augment it with this metadata. So as you see here, when you run this OpenNLP, I don't change the text of your data, your message events. I add my analytics around it. So you can still have that original data unchanged and do with whatever you want with it. And then you can pull out all these attributes that have things like, the entities in that text and use them for something. I could use it for queries. I could use it for routing. I could add it to the data, or I could pull out all that metadata and have that as a separate stream of data. So I can have a table where I populate it with my real data and then with this created metadata. And it uses some standard pre-built OpenNLP models, which again, with open source, if you want to write your own NLP models or you need to write them for your language, by default, they have a number of languages. Fortunately for me, the English is supported, so it makes it a little easy. I've got links here to details on this. So when you get these slides, I'll make sure that they're posted through the Big Data Conference, and I'll have them on my site so you can easily get all these additional details like, how do I go more with this? There's articles right there. I mentioned MXNet for deep learning. Again, I have this integrated with NiFi, so you could do things like, single shot detection. I've got a number of them out there, and these are really nice because NiFi doesn't just handle text or structured data like CSVs or XML. I can also handle images and video and audio. So I'm using the Java API there to do that, and we'll show you some of that if we have time. Fortunately, the Apache MXNet community has expanded, and they've released a native deep learning interface for Java. This is a really awesome way to be able to do deep learning. It's related to the MXNet, and it can use that MXNet engine, but it can also use the PyTorch one and TensorFlow, and that really opens up a whole lot more avenues for using models. I'm a data engineer and not a data scientist, so I'm not usually writing my own models, maybe retraining one. So I could use that pre-built set of models in the model zoo from MXNet PyTorch and TensorFlow, and then just deploy them as part of a Flink data pipeline. Makes it very straightforward. Again, I mentioned those attributes. Again, I like to put the results in attributes so you still have your data. And in this case, the data is an image, but I have all this metadata around it saying this is where what we found was, this is the classification. Very easy to do. I've added some more recently as they've added more pre-built models. They have one for sentiment analysis with deep learning, which is a really nice way to do this. It seems a little better than some of the uh, more older standing ways to do sentiment analysis. I do have a processor out there that uses Stanford Core NLP, which is another option. So far, the Deep Java Library sentiment analysis model has been looking really good. It's pretty good at determining, how positive or negative the sentiment of text is. So I'm giving you a pretty detailed set of results there, so you can determine if you think something is positive. If you look here, 99% negative, it's probably negative sentiment, and I give you the raw classification if you want to work with that as well. Very easy for you to customize it. Again, there's an open source component for that. Now, this one is really interesting, and I've been considering writing some kind of interactive AI with this. I wrote a component around the disto-BERT model through PyTorch and DGL. What's cool here is with BERT QA, I can do questions on my text. So as this textual data is coming in, I can ask questions on it and get usually pretty interesting answers. Now, if it's not something that has been pre-trained on, it might not be the perfect result, but it makes for interesting data. And I could, plug this into a Slack group and make sort of a semi-intelligent bot here. Or if I just want to use this to get some, detailed information around the data that's coming in, I could do that, try to pull out results so I don't have to manually go through a big set of text. I could ask a question like, when was this published? Are there what's the main location for where this, happened, whether it's an article or whatever it is. This could be helpful in, medical data or other data. There's a lot of text, and you might want to get some quick ideas so you could categorize what you should do with it. It's just idle chatter, or is there maybe some important information that someone should take a look at? We might be able to distill that by using this model. So I mentioned a lot of things. Again, Apache NiFi and its little cousin Minify are the backbone of this, because they really do the orchestration, the movement, the acquisition of our data and help me distribute it where it needs to be. So whether I'm putting an agent somewhere, and that could be as small as a Raspberry Pi or even a little smaller. So if I want to put this, I have this in trucks, I have this in ATMs, gas station devices, moving trucks, trains, planes, automobiles, laptops, tablets, small old servers, in scanning devices in factories. Even we could put this in a shipping container. So we can grab that data, securely send it to wherever your infrastructure is. People tend to have some small set of clusters closer to where they're running these edge apps. So, if you have a warehouse that's shipping out trucks, in that warehouse, I probably want to have some level of NiFi cluster, even if it's a couple of nodes, just to do some local processing. You might need information right away, and you don't want to wait till it gets to some cloud infrastructure, and I can do that. NiFi handles all that for you. You don't have to really think about, well, how do I get it to that next step? It's trivial in NiFi or Flink. And looking at it, it looks like something that I'll just run on my laptop. Is it powerful? Is it not powerful? That's up to you to decide. But we've done some benchmarks here in the most recent version, which I recommend you run NiFi 111.4 or 112.1. This can support a lot of data at a time. We're talking millions of events a second, even on a single node or small cluster. Big chunks of data, because remember, I can move binary data, I can move zip files, images, or I can move things that are records. I've got, almost 1 million records that I need to process. Well, I could do that in a second. Depending on if you need to scale up, it scales very linearly. Just add some more nodes. We don't usually tend to scale too big up. The nodes are not big when you consider how big data servers are or data engineering servers are. We tend to like 32 gig of RAM, 16 to 32 cores. Those are not massive machines. Pretty affordable, but they can push through a lot of data, whether you're running it on premise, any of the major clouds, in Docker, and soon we'll have a specialized release for Kubernetes, which makes it even easier. But the results are out there. Let's show you this. It's easy to talk about it, but let's show you what we could do. So this is a NiFi environment. It lets you put nice colored boxes in here. So if you want to be able to determine what you're doing, it makes it a little easier when I separate these out. And since I do a lot of development, I have access to all my apps here. If I'm in multiple teams, I can make it so I only see mine or just my teams, and other people see their own, so they don't have to see, a ton of things on their dashboard. So this is NiFi. It has some higher level information on the top, like how many nodes in this cluster. I'm trying to keep it cheap, so I have one node. I only have a couple of tasks. I can see what's running. I can get more details on everything going on because I don't remember what's going on, what started, what stopped. There's a lot of data over on this one. I might want to clear that out because 27 gigs of data is a lot of data. So I'm curious what's going on with my system here so I could directly clean it in. I don't see that right now. See, yeah, that's how much has gone in before because it's constantly running here. And I could take a look at what we call data provenance. This is what's happened, what's gone through the system, and you get access to all those attributes I mentioned, and you can get all the metadata that may be of interest. Here, this is connected with WebSockets, so I can see all that WebSocket information. Also unique to NiFi is every event or message or file, whatever that unit is, we call it a float file, that has a unique ID we put on there for you. So if you're trying to track what happened or follow your data through the data life cycle, you have this unique ID. And you can, if you want, you can add that to your data or just have that as that metadata that goes along with it so you know what's going on. I also have access to my content. I can see how it changes over time. This is a very important way to see what's going on with your system. That's a lot in my cache. I'm watching what's going on here because what I have here is NiFi doesn't just let you ingest data. I'm using it also as a way to channel to get that data out. So I have an actual single page web application I'm hosting here, and this is the code for it. And I'll show you what we can do here. I set up a port, tell it it's standard HTTP, allow all those kind of headers you want, let people send data if they want to. Then I'm just going to grab a web page. It's just a simple HTML page. I've got the source for that so you can see it. I'm not a front-end developer, so it's not pretty, but it works. And I'm just, hosting that page and listening for WebSockets. And I have a cache here that lets me send data back to that page. So I have that automatic updates as our data changes. The other thing I'm doing is if you're on that page and you want to send me data, you can send it through a WebSocket interface, and then I'm taking those data that's coming through and I'm sending it to Kafka. So I can publish that and share that with other people. This is very simple to do in NiFi, but I've made this so I can run a web page, this web page here, and it's getting data on weather. I'll show you how we get this data into the system. It's a very simple app, but as we get more data, I'm just adding it to the scrolling text area, and it's basic JavaScript and HTML. There's nothing fancy. It's in one web page, basic CSS. This is not a place to learn how to do the best web application programming, but it shows you the art of the possible. I can host, a live WebSocket app that pushes data in and out. So if I want to send some information on, this is me, I want to say this is an awesome conference. Hopefully you're enjoying all the content. I wish I could be there in public. This is early in the morning on the East Coast, not as much fun as being in a beautiful city somewhere, but what can you do? So we've sent some data and I can process that data. It comes through. We've gotten the data. I can see that it's come in by looking at the provenance data. This is great when you're developing or testing. This was the previous one. We can look as it comes through different times, what data came in, what we did with it, what was my message. And we take that data and we build up a message to send to Kafka in a standard format. Fortunately, once it goes to Kafka, I can see what's going on with it. Makes it very straightforward. I have alerts here to say, hey, Tim, you haven't been sending a lot of data because I was sleeping and I didn't want to send data while I'm sleeping. But here is my interface to Kafka. This is something called Cloudera Streams Messaging Manager, or SMM for short. This is a great dashboard to Kafka. If you've seen Kafka before, it's often messy, hard to see. So we sent it to Kafka. Let's see what we should be sending. We're sending it to this topic. I'm sending it as Avro. If you don't know about Apache Avro, it is another great thing from Apache. This is a nice format for putting your data, and Kafka really likes it. It's binary and a little better than just having JSON, and it's very good for applying a schema. So we've got a schema. I've got a name here that tells me who's pushing this data out. So when I come to SMM, I could see all that sort of information that says this was who produced the data, and this is who's consuming it, and what are they doing with it. So now I know data's coming in. I could see all the internals for Kafka here. I could say this is Avro data and this is the schema, so I could quickly check that. Or I could go to my schema registry over here and I can see, okay, these are the fields. Do they support null? They don't support null. Those sort of things. And I could examine the data to say, okay, that was the message someone sent me. They sent me an empty message. This is what they called. This was the message date, all that sort of information that helps me for this. And I put a key in here in Kafka. Again, more ways to track what's going on. So I could take a look at that producer, see who's actively producing. I've got different applications. This one's not doing much right now. Makes it easy. I could see if there's anything slow, and I could see this one is. So my Flink app is not doing much here. So we should take a look at that app. I also have some Kafka Connect apps here, doing different things. So if I have this weather data coming in, I can check it. You saw the weather data is what we're displaying in that other app. I should make sure we're getting data in. I have it set to run every 10 minutes, which is probably not frequent enough. but the weather data forecasts only really get updated a couple times an hour. If you look here at the high level, you can see we're starting to get a few thousand records in, and they're queued in and then they come out. What that means is we have these little queues in between each step. So when I'm coding, I don't have to know the end result while I'm coding, and I can run it live while I'm developing, which is great if you're not exactly sure what you want to do. Here I do. I want to make a REST call, grab a zip file, unzip it, uncompress it, and then route only the ones that have a certain file name to my system to use. And I'm going to convert XML to JSON. Very straightforward here. I do that with this SQL statement. Makes it very easy to do. Hopefully this is a good size to see. So I get those results out, and then what do I want to do with them? As you see, I just processed, 30 megs of data. Comes over here. I'm going to tell NiFi what schema this is, so it doesn't have to guess. And I'm going to set this to weather, because this is weather data. And I can look down here. I've got one for weather. It tells me the different fields, and they're nullable, it's string, all that sort of fun stuff. And here I'm going to validate it, because sometimes of these XML files, some of them are damaged, or they're missing files that I wanted to have. So I'm going to say, you can give me extra ones, but don't take away ones that I need. I'm not going to be too concerned on the type, because I can always convert it into a string or vice versa. It's not as important when I'm dealing with data in Kudu. It's very flexible. So I'm going to use the schema registry, which we saw over here, to validate this data coming in against that schema. So don't send me junk. Don't send me stuff that isn't what I asked for. Just give me what I want. Maybe you could throw in a couple extra fields. I'll ignore them if I don't care about them. Or I could change my schema later, or change my data store later to support that. And I'm going to take this data again, push it into Kafka based on a couple of easy criteria. And this is who's doing that. Again, that way we can see who's pushing to what. Here I only have a single server. You can see a bunch of things are active. Here's this weather guy. So I could filter based on that. I could see he's only going here. I could see there's 2 people reading them. We were in that Kafka Connect app. He's reading it, and so's NiFi. Again, very easy for me to pop into here, see the number of messages, see the actual data, explore the data and go, hey, there's funky characters. That's because it's Avro, and it has a schema. So if I need to see it, I'll just apply the schema, and I can go back and look through all the 30,000 messages here, check where my data is. A little easier is I'll go through NiFi and see what the process is. So I built the data, I sent it to NiFi, and now I'm going to a little big here. Let's see, and then I'll read it in. As you saw, we just read in 20,000 messages, and I'll show you why I like Kudu as our second reason to have the K in the flank. So I'm reading this data, very easy to do, and I could watch this consumer here, and I'm going to store that in a Kudu table. And this is it. This is all the code to do that. One step from Kafka to Kudu, real-time streaming, easy as can be. I put the table name, I put the server name, I put what kind of records I'm reading, and I put what kind of operation. I could have done insert, but upsert makes this a great thing, because they sometimes they send me the same data twice. And, that's not my favorite, but if you want to do that, fine. I'm fine with you doing that. So I get a bunch of data in, and it's in a table, and I can query it just as if it's any other data. And I didn't have to type any SQL. I just put the table name in, and it knew location is location. This one goes to this field. This is the type. and it's got all these different fields I have in there, from the weather report, lat long, temperature, all those sort of fun things. Makes it very easy for you to do do reports on this and see what the data is. I'm going to look at the temperature. I can look at the weather and see what the data is. And I can put this into a report or a dashboard or a visual app, so I could see different airports, what their weather is in Celsius, and a description of what's going on there. It's raining, it's cloudy, that sort of things. Makes it very easy. That's just one thing we could do with the data. The last part of this is the Flink part, is Flink. Flink is a great tool to do this. So I wrote an app that deals with the weather. Now, this is not the title. This is the application. Again, as simple as can be. The title they make is the SQL statement I used. So I went over here to a quick interface to run these SQL queries. And those SQL queries can be something like just a select star, but it can also be something like this, insert. This insert is building data into topics. We don't have any questions out there. Hopefully you're following along and enjoying, or I don't know what time it is for you in the world, but for me in the world, it's pretty early. So I could probably use 10 or 15 more cups of coffee or some really strong espresso. But we have that data and I'm inserting it in over here. Let me just pop into Slido. Okay, nothing updated in there yet. I'll be in the other places when we're done. But as you see here, in that simple statement, I inserted this into Kafka. And I did basic processing here. I changed a couple things to string. I took just the fields I wanted. And I also made sure that there was a location and it matches NJ. For those of you not familiar with the United States, NJ is an abbreviation for New Jersey. That is the state I'm in on the east coast of the US. So I just wanted to see the weather that's near me. Seems like a reasonable ask. So I'm going to grab the weather that matches that and put that into another Kafka topic. So as those events are streaming in, this statement is running, and it's a distributed Flink app, and is going to grab those events that match that criteria and put it into another topic. So as data comes in, it will show up over here, and then I could use that in another application, put it in a dashboard, put it in a web page like this if I wanted to just show the New Jersey one. This is grabbing the regular weather data, which I have all the parts of the US here. It makes it easy to do that. I'm also sending that weather data to Slack. Makes it very easy for me to do that in NiFi. The interface for Flink is very easy. I'll show you over here. I'm pushing, I've got a lot of data backed up because I haven't started my Slack queue yet. Again, another nice feature with NiFi is these configurable queues and the fact that I could start and stop things anytime. I'm out of time. Thank you for coming, and we'll see you again in the future, and I'll give you all this materials. See you in the Ask Me Anything. Thank you.